Hey y'all, today we're working on that 2-5 lesson review. This will help you greatly on your Savvas lesson quiz for this lesson. So take good notes and pay good attention because hint, hint, wink, wink. Number 1, the graph shows a proportional relationship between water used and the time in minutes. What does the point 315 represent in this situation? So I'm first going to identify that point on my graph. So 315 is going to be this point right here. Okay? Now remember, when we write an ordered pair, we always write it with our x coordinate first and our y coordinate second. And that's going to help me describe what this point represents because I'm going to start with my y. So 15 is my y. And that corresponds to my y-axis, this vertical axis right here. So 15 means that 15 gallons of water are used. So that's exactly how I'm going to start. 15 gallons of water are used. Now I'm going to look at my x. My x represents time in minutes. And since 3 is my x value, that means 3 minutes. So 15 gallons of water are used in 3 minutes. And that's what the point 315 represents. Moving on to number 2. The graph shows a proportional relationship between the distance driven and the time in hours. What equation relates the distance, y, and the time, x? So first of all, we remember from lesson 2-4 that we can write equations for proportional relationships as y equals k times x. So all we have to fill in with this blank right here is the constant of proportionality. So we need to look at our graph to find our constant of proportionality. And remember, we can pick any point on the graph, and we know that k will be the y coordinate divided by the x coordinate. So any point on the graph will work. So looking at my graph, I'm just going to pick this very first one. It's easier if I work with smaller numbers. So this first point is 155. So remember, we write our x coordinate first and our y coordinate second. So going back to where I wrote my formula here, k equals 55 divided by 1, which we all know is just 55. So I'm going to plug in 55 into my equation right here. Y equals 55x, which means 55 times x. Okay, moving on to number 3. Which graph shows a proportional relationship that passes through the point 3, 1? Okay, so first of all, the graph of a proportional relationship has some key characteristics. The first thing is we know it has to be a straight line. If it's anything other than a continuous straight line, it's not a proportional relationship. And when I look at all 4 of these, they're all straight lines. So I'm going to think about the other key characteristic of proportional relationship graphs. Proportional relationship graphs always pass through the origin, which is the point 0, 0. So 0, 0 is this point right here in the corner. So A works, B, it passes through 0, 0, so that one works too. C, look, there's the origin and the graph isn't anywhere near it. So C does not work. And D is the same thing. The origin's down here, but the graph is nowhere near it. So right off the bat, I can eliminate C and D. So now I've just got to determine which graph between A and B is proportional, but also passes through the point 3, 1. So the point 3, 1, remember 3 is our x value and 1 is our y value. So looking at A first, our x-axis is this horizontal one and our y-axis is the vertical one. So 3 along the x-axis and 1 along the y-axis is that point right there. This right here is the point 3, 1. Is our graph anywhere near it? No, so it can't be A. So let's look at B. Remember, our x-axis is here and our y-axis is here. So along the x-axis, 1, 2, 3, up 1 for the y-axis. So that right there is the point 3, 1, and it does pass right through that point. So B is our answer. Oops, fix that. There we go. Okay, moving on to number 4. This one's probably one of the trickiest ones. A graph is a straight line through the point 0, 1. Can the graph represent a proportional relationship? Explain. Well, first, I'm actually going to draw this out. So we don't need to draw anything big, but here we have, and I'm going to line that up a little bit better, our x-axis and our y-axis. And we know that our origin is that point right there. That's the point 0, 0. Okay? Now, let's see. Let's give myself, like that's 1, 2, 3, 4. So 1, 2, 3, 3, 4. Okay? So I'll go back and label those 1, 2, 3, and 4 along the x-axis, 1, 2, 3, 4 along the y-axis. So 0, 1. Remember, our x-coordinate is first and our y-coordinate is second. So 0, 1, well, 0 is right here, but 1 means I move up along the y-axis 1. So that's that point right there. So that means that our graph is going to be a straight line extending from that point. So does it pass through the point 0, 0? Does our graph pass through the origin? No, it does not pass through the origin. So can this graph be a proportional relationship? The answer is no. It is not proportional. Okay? And the reason it's not proportional is because the graph does not pass through the origin. Okay, moving on to number 5, use the graph to determine whether there's a proportional relationship between the number of round tables and the number of chairs. If so, what does the constant of proportionality mean in this situation? Okay, so first of all, we need to determine if this is a proportional relationship. So I see that my graph is a straight line and it starts right there at 0, 0. So yes, this is a proportional relationship. Okay, so now that we've determined that it's a proportional relationship, we can figure out the constant of proportionality. So to find our constant of proportionality, and remember, k is our variable that represents that, and we find k by picking any point on the graph and taking y and dividing it by x. Okay, so we have to do that, and it doesn't matter what point we choose. I'm going to choose this one right here because it's small numbers, and that is the point 2, 10. Remember, we always start with our x coordinate and then our y coordinate. So to find k, I'm going to take 10 and divide it by 2. So 10 divided by 2 is 5. So k equals 5. Okay, now that I know that, I can plug it in right here because it means that each round table has 5 chairs. And that is the end of our 2-5 review.